Hey everybody, in this video we are going to talk about some details of functions like degree, leading coefficient, zeros, end behavior, relative and minimums and maximums, increasing and decreasing intervals. So we'll start here with this function, state the degree. So the degree is the greatest exponent of the variable, and that is 4, so the degree is 4. Okay, so next we want the leading coefficient. The leading coefficient is from that same term where we found the greatest exponent. The coefficient there is 7, so the leading coefficient is 7. Now it says name the function. If it has a degree of 4, it is a quartic function. Okay, now here we have a function that is graphed, and we want to know the number of real zeros. How many real zeros are there? Real zeros are places where the graph crosses the x-axis, so it's the x-intercepts, and I see 1, 2, 3, 4, 5, 6 real zeros. Describe the end behavior. So for end behavior, first we'll talk about the left side. As the graph goes left, that means that it's moving this way, and the x value is going toward negative infinity. So as x approaches negative infinity, what is the y value doing? It is going upward. The y is approaching infinity. Then we talk about what happens as the graph goes right. So as the graph moves this direction to the right, so we say as the x value is going toward infinity, what's the y value doing? The y value on the right side is also going up, so y is approaching infinity. Okay, now the degree. Okay, so to find the degree, you can count 1, 2, 3, 4, 5, 6. The degree appears to be 6. Okay, now on this graph, we start with the number of real zeros. I see 1, 2, 3 x-intercepts, so there are 3 real zeros. Describe the end behavior as the graph goes left. So as the x value approaches negative infinity, this graph is going down. So the y value approaches negative infinity. As the graph goes right, so as the x value approaches positive infinity, this graph is going up. So the y value is going toward or approaching infinity. The degree appears to be 1, 2, 3. So next, what about a relative minimum and a relative maximum? Okay, now this one does not have an absolute minimum or an absolute maximum because it's pointing downward forever, pointing upward forever, but it does have a relative maximum here and a relative minimum here. So for the relative minimum, we're going to write a set of coordinates. It looks like it's a little bit past 0.5, so we'll call it 0.6. So it's 0.6 units to the right and maybe a little less than a half unit down, so we'll call it negative 0.4. How about the relative maximum? So it's farther left than 0.5, so let's call that 0.6, but that's negative because it's to the left, negative 0.6. And the y value is a little less than 0.5, so we'll call it 0.4. Then we need to describe any increasing or decreasing intervals. Now, as I trace from the left, this graph is going upward first, so it is increasing first. Okay, then let's just tell what the domains are doing or what the intervals are doing. Next, it's decreasing. after we write what's happening on each interval, we'll list the domain for each interval. Then it's increasing again, and it keeps increasing forever. So this first increasing interval, it stops increasing right here when we get to an x value of negative 0.6. So for all x's left of negative 0.6, so that is for x's that are left of or less than negative 0.6. Okay, so there's the domain for the first increasing interval. Then it decreases from here until it gets here. So we need to know the domain here. The domain here is all x's to the right of negative 0.6, so that's greater than negative 0.6, but to the left of 0.6, so less than 0.6. And then it begins increasing again, and it's increasing forever to the right of 0.6. So it's increasing for all x's that are right of or greater than 0.6.